Okay, today's lecture is going to be on 2.5 and 2.6. 2.5 is applications of percent problems. If you look at a percent problem, the of, like if it says 25% of something, the of translates to multiplication. So of means multiply. The is part would be equal. So if it said like 25% of 100 is 25, the is part would be your equal. The percent part would translate to that number over 100. So whatever that number is over 100, or that number times, what's times 1 over 100 is times 0.01. So as a decimal it would be this, as a fraction it would be that. So when you do these problems, if you have like, it says 28% of 5 is what number? Okay, the 28%, this part translates to 28 over 100 or 28 times 0.01. So it's according to whether you want to use a fraction or a decimal. Okay, so you could say 28 times 0.01 is 0.28. That's just moving your decimal back twice. Of translates to multiply. Of 5 is translates to equal. Is what number? Okay, you can do it like this, and you're going to be solving an equation. If it's just the two numbers here, you multiply them, and that gives you your answer. 5 times 0.28. 1.40 is what x is. Okay, there's also another way you can do percent problems where you're not actually solving an equation, it's a proportion thing. Have I showed you that one before? The is over of equals percent over 100. This same problem, you could have put the is this part right here. Is your is, here's your of, and here's your percent. The is what number? So just, you don't know what the is. The of is 5. The percent is what? It's 28. And that all goes over 100. So you would multiply 5 times 28, you'd multiply the two numbers that are crossed, and divide by 100. You're going to get the same answer. So you can either do these as a proportion, which is the simplest way. Just plug it into this little magic equation right there. Let's do 45% of what number is 28. Okay, here's your is, here's your of, and that's your percent. Okay, so put is over of equals percent over 100. You don't have to write this part every time, but you do need to plug the numbers into this part. Okay, the is on top, put it 28 on top. The of goes under it. You don't know the of, so that's a letter. Put an X here. The percent is 45. So right here, you put 45. And the 100 goes down here. See how you don't have to do any converting? Like this one, you turn it to a decimal or fraction. When you plug it in here, you don't have to convert the numbers. You just plug them in straight in there. Put the 28 straight in there. The X is your of, it goes straight there. 45 goes straight there. 100's there. This one, you're going to multiply these two. It's always the two that are across that you multiply. And then divide by 45. So 2,800 divided by 45. And what does that come out to? 62? Yeah. 48% of 62 is 28. So you plug them in. I don't think it makes you actually translate it to a specific equation. So you don't have to do it the way they wanted it done this way. You can translate it into this thing. You put it into this and solve it. So all of the page 177, you're just going to be putting them in. Let me see. Let's pick one. Let's see. 54. Number 22 says 54 is 24% of what number? Okay? Put your proportion there. You don't have to write the whole thing down every time. You don't have to write it out like this. Okay. What is your is? 54 is your is. Your of you don't know. Okay? Your is on top. Your of goes on bottom. Percent goes over the 100. The percent is the 24. And the 100 goes on bottom. So you're going to multiply what? 54 times 100. Then you'll divide by 24. 225? Yeah. Okay, so this is all you really have to show for work. You could do it on your calculator, just show what you multiplied and show what you divided. Okay, you don't have to actually show all the multiplication and all the division. Okay, you have some word problems that have percent. Let's jump over to where there's some tipping. Page 179, there's quite a few problems that have tips involved. Okay, number 41, it says that Leon left a tip, he left a 15% tip per meal that costed, this is the meal, that costed $25. Okay? A says how much was the tip? How much was the tip? Okay, the tip is 15% of the meal, right? So you could put the tip is 15% of $25 is your tip. So then you know how to plug it in. Right, 15% of $25 is, if you put it into words like this, then you'll be able to plug it into your proportion easier. Put it into a word problem that says percent of this is that. Your is, you don't know, so you put it on top. The of goes on bottom. Your of is 25. 15 is your percent that goes over 100. Okay, so what numbers are we going to multiply? 25 times 15, then you'll divide by 100. So the meal came out, the tip came out to $3.75. Okay, the B part says what was the total cost of the meal including the tip. So the meal plus the tip, right, is your total cost of the meal including the tip. So there's your meal and your tip. So your total cost, just add them. $28.75. Okay. When you read these word problems, make sure you put it into something percent of something is something. Go ahead and put your word problem where you plug your numbers into here, and you'll be able to solve it easier. Okay, let's see. Number 43 says Leon left a 15% tip. You know that's going to go where the percent is, right? 43. Leon left a 15% of $4.50 for a meal. That's saying his tip is $4.50, right? Not his meal was $4.50. So 15% of his meal is the tip. So you want to put the tip where the is part is $4.50. So we want, A says what was the cost of the meal before the tip. Okay, so that would be your of. What was the price of the meal before the tip? And we could even put it in there instead of an X. It doesn't matter what letter you use. Okay? We're using is over of equals percent over 100. The is your tip, $4.50. The of is your meal. Equals, the percent is 15 over 100. Okay. Which numbers are we going to multiply? The ones that are across from each other. 450 times 100. Multiply those. And what do you do to 15? Divide. So 450 times 100 is 450. Divide that by 15. 30. So the meal was $30. And then B, of course, what was the total cost of the meal? So you'll be adding the meal plus the tip, right? Plus the tip. The A part is your meal. The B is the meal plus the tip. So you add that, you have $34.50. Okay, let's do one that's not a tip. Number 45. Portland, Oregon has 12,959 acres of park space. It says this is 15.1% of the entire city. So this is 15.1% of the whole city. So we could do the C for the whole city. What is the total acreage of Portland? That would be your city. So do your is over of equals percent over 100. What is your is here? This long number, right? So let's make this line a little longer. 12,959 is your is. What is your of? C. Of is your C. Percent is 15.1. The percent goes over 100. So you're going to multiply 12,959 times 100, which adds 2 zeros to it. Multiply those, divide by 15.1. So what did you get?
85,821.19.
0.19?
Yeah.
Okay. In the book it says about this many. So the 0.19 you can drop it or you can leave it on, it doesn't matter. What is that? Acres. You could put the 0.19 or leave it off. The book says about 85,821 acres. So, oh, that's not one of your problems anyway. Let's see. I don't see one of yours that says, oh, number 34, it's going to be rounded on the answer. You can leave it rounded or not. Let's set it up for you, but not do the work for number 34. Okay, sales of cars average 26 million. 26 million is the sales of cars per dealership in 2007. Of this amount, new car sales accounted for receipts of 24 million. What percent of the total sales are new cars? Okay, a percentage of this is how many were new, right? Of this amount. So it says a percentage of this amount is the new car sales, which was 24 million. Okay? So we're trying to find the percent part. Is over a, your is going to be your 24. If you just put 24 and not the million, that's okay. You put the 24 and the of is 26. And it's still going to come out as long as these are both the same. If one of them was 1,000 and one was million, you'd need to put all the zeros. But since it's like this, you can just put the numbers. The percent, you don't know. What do we put on bottom? 100. Percent always goes over 100. When you multiply these, it should give you, multiply and divide, and that'll give you your answer. In the book, it's rounded to a tenth. It's probably going to come out where it's not a tenth, but you can put either the exact or round it to the tenth. Okay? If you want to get the book, the answer that's going to show on the answer sheet, it'll be to the tenth. Okay? I think we did enough of those. Okay, 2.6 is all word problems. I know you're going to love this section, huh? Okay, if you look at some of the problems, the examples, you always see a picture and it's divided up. Okay, if you look at page 182, there's an example that has a picture of a what do you call it? Thing around your neck? A shawl? Is that what they called it? Scarf? Shawl? Yeah. The things that go around your neck. Okay. You've got this long rectangular thing. Okay. The page before told you what the things were about that scarf. Okay, without looking at page 182, look at page 181, and it shows you, it's just the word problem part of it. Okay? It says, Lily knitted a scarf in 3 shades of blue, starting with light blue. So you're going to start like with light blue. And then a medium, and then a dark. Okay, light, medium, dark. Okay, then it starts getting a little harder. It says the medium blue is 1/2 the length of the light blue. So this part is 1/2 of this. So we need to give this like a letter X. So this is 1/2 of X. The light blue is X, the medium is 1/2 of X. And then it says the dark blue is 1/4 of the light blue. So it's 1/4 of the X, right? And it says the scarf is 7 foot long. So from here to here is 7 feet. Find the length of each section. But it only has 3 sections, right? It didn't do like this over and over and over. So the way I drew it's not exactly like they drew it on the next page. This was the whole scarf. It was light blue, and then medium, and then dark. A real scarf, you wouldn't do that, huh? You would keep rotating it, light, medium, dark, light, medium, dark, light, medium, dark, something like that. Okay, their whole scarf is this part right here, from here to here. So they just have these 3 things right here that add up to 7 foot. Okay, so you have 1/4 of X plus 1/2 of X plus X is equal to 7 foot. Okay? Does that make sense? Yeah? This whole thing was 7 foot. Okay. If we add all these X's up, what are we going to get?
We're gonna get 7.
Huh? Yeah, we'll get 7 feet. What if we add these, how much, what are we going to get in front of the X here? We'll have 1 plus 1/2 plus 1/4. Yeah, 1 3/4. We have 1 plus 1/2 plus 1/4. So you have 1 1/2 and 1/4. So we need a common denominator. So 1/4 stays 1/4. 1/2, you have to multiply it by 2 is 2/4. So you have 1 plus 3/4. So 1 3/4. You're just adding the coefficients. The numbers in front. Okay. So you have 1 3/4 X equals 7. Okay. What do we do with this number? It's multiplied here, so we need to divide it, right? Let's turn it into improper before we divide it. 4 times 1 is 4 plus 3 is 7. 4 X. Okay. To get rid of this, we're going to divide by the 7/4 or multiply by what? When you divide by a fraction, you multiply by the reciprocal. So let's multiply both sides by the reciprocal. So this turns into 1x is x. And what's over here? 28 over 7 or just 4? You could divide by 7 here and here. So x is 4 what? This was in feet, so it'd be 4 feet. So the light blue is 4 feet. The medium is half of that. So the medium would be 1/2 times 4, or half of 4 is 2, right? 2 feet for the medium blue. And then the dark blue was 1/4 of it. What's 1/4 of 4? Just 1. 1 feet of dark blue. Make sure that adds up 4, 5, 6, 7. See, it adds up to 7 feet. it may end up like this where you drew it wrong, like I did. And just say, okay, well, this part we didn't need, this part was 7 foot. You have a pencil, you'll be able to erase yours if you draw it wrong.
Can you put that back down, please?
Put it back up there?
Please.
Okay.
Thank you.
Everybody got it? Okay, look at the example on hiking. It says, at age 79, Earl Schaefer became the oldest person to hike through this, that doesn't matter, right? Okay, he hiked through all 2,100 miles of the Appalachian Trail. The 2,100 matters. He hiked through all 2,100 miles. So 2,100 is how far he hiked. Okay. Schaefer through hiked, what is that? What's that? I guess I'll have to read the whole thing. I was trying to skip the part I didn't need. Okay, from Springer Mountain, Georgia to Mount Kadim, Maine. Schaefer, it still looks funny, through hiked the trail 3 times.
You're saying he did it.
He did it 3 times? Oh, Schaefer through hiked the trail 3 times in 1948. Oh, from Georgia to Maine. But not the whole thing, right? In 1965, Maine to Georgia. And in 1998, Georgia to Maine. Wow, you really need a picture for this, huh? In Georgia to Maine, near the 50th anniversary of his first hike. At one point in 1998, Schaefer stood atop Big Walker Mountain, Virginia, which is 3 times as far from the northern end as from the southern end. How far was Schaefer from each end of the trail? All of that other stuff up there doesn't even matter, huh? Yeah, it's just saying he stood somewhere and he was so far from stuff. So all that middle stuff is a whole bunch of useless information.
Trying to confuse us.
Yeah, and you're going to have to be able to sort through what's important and what's not important. Okay? This was important, how far the trail was. Okay, now when he stood atop that peak, this is what's important, that very last sentence. He stood atop a peak, which is 3 times as far from the north end. So we need a picture, right? Here's, if this is the north end, and he stood here, right here it was 3 times as far from the north peak as from the southern peak. This is your southern peak. So
So who's in the middle?
there's
Not
kind of
quite.
somewhere in the middle, yeah.
Not a third.
But he's 3 times as far from the north peak as he is from the south peak. If X is how far he was from the south peak, he's 3 times as far from the north as he was from the south. Okay? And how far is this whole thing from here to here?
21.
There you go, 2,100 miles. Okay, so what would you do with these 2 numbers to get the 2,100?
We'd add the.
You'd add this distance to this distance to get this, right? This plus this is the whole 2,100. So you'd add the X plus the 3X to get the 2,100 miles. If you add these 2 X's, what's on this side? 3 plus 1 is 4X. is 2100. So divide by 4, it gives you 4 into 2100. Is about 525. And what is this in? Unit.
Miles.
The unit is miles. Okay. So that would be how far he was from the south peak. If it wanted to know the north peak, you just multiply it by 3, right? And we won't do that together. Okay. There's a way they'd want you to do consecutive numbers. And instead of doing the exercise out of the book, you can always look back at it. Let's do one of the problems that has consecutive integers, okay? Because that's the next example, but we're not going to do the one. You can look back at this one. Let's find a consecutive integers problem, and we'll do it. Okay, your consecutive integers ones will be 9, 10, 11, 12. There's going to be a lot of them. Okay, what they want you to do, we'll do number 11. Okay? It's got 3 consecutive integers. Okay, it says the numbers on Sam's 3 raffle tickets are consecutive integers, which means consecutive means 1, 2, 3 order. Okay? They're consecutive integers. The sum of the numbers is 126. So what are the numbers? So if they're consecutive, if your first number is X, what would your second ticket, what would the number on it be?
X plus
1 more, right, X plus 1. The third ticket, if you had X here,
1, X plus 2.
plus 2. Okay? So this is the numbers of the 3 tickets. What did it say they add up to? 126. Right? Is what they add up to. So if you add this plus this plus this, so you're going to add X plus 1 plus X plus 2. That's your 3 tickets, and it equals 126. Okay, so you have X is 3X. The numbers 2 plus 1 is 3. Equals 126. Okay, so you can do what first? Subtract 3 first. That leaves 3X on this side. 126 minus 3. 123. Divide that by 3. 3 into 12 is 4. 3 into 3 is 1. So your first ticket's 41, but you have 3 answers because you need all 3 ticket numbers. So the answers are 41, 42, and 43. That's your 3 ticket numbers. And you can check, you can add those 3 numbers and make sure they add up to 126. And if it does, you know you got it right. Okay, sometimes you have consecutive even numbers or consecutive odd numbers. Okay, let's say you have 3 consecutive even numbers. This one isn't in the book. Consecutive even numbers. And that's 3 of them, okay? That add up to 42. Okay, now let's use x's to figure out what those numbers be. The first number is x, okay? If they're even, what's your second number going to be?
Plus 2.
Plus 2, because it's every other one. The third number? plus 4. So we're going to add these three numbers to get 42. So x plus 2 plus x plus 4. That's the three numbers. And they add up to 42. So you have x is 3x plus 4 plus 2, 6. And write equals 42. What's the first thing you do to solve it? Subtract 6. So 3x equals 36. Divide by 3. X equals 12. So what are the three numbers? 12, 14, and 16. You're going to use the same thing here for even or odd, because both of them are every other number. Okay. Let's do you're going to do number 23, so I'm going to do 24 with you. It's a triangle. Okay, number 24, it says the second angle of a triangular parking lot. Okay, if it says triangular parking lot, I would draw a triangle, because you know that's the shape that you're working with. The second angle is 4 times as large as the first angle. So let's just put first, second, third. The second angle is 4 times as large as the first angle. So if we name the first angle x, this would be 4 times as large as that. So it's just 4x. Okay. And then it says the third angle is 45 degrees less than the sum of the other two angles. So this one's going to be a little more, is 45 less than the sum of the other two together. So this plus this is the sum of it, right? This x plus 4x is the sum of the other two. So this actually, if you simplify this part, x plus 4x is 5x minus 45. This would be easier to put in to an equation than this whole thing. Okay, so how large are the angles? What do the angles of a triangle add up to? 180. All three of these will add up to 180. So you're going to say this, the x, plus the 4x, plus this, 5x minus 45 equals 180. So we'll write it x plus 4x. I like to underline them, just let myself know what I'm doing. It's this, this, and this. 5x minus 45. These three angles add up to 180. Okay, let's combine all of our x's over here. 5 and 4 and 1. So that's 10x, right? 5, 4, and 1 add up to 10x. And then we just have the minus 45. Equals 180. So what was the first thing to do to solve this?
Add 45.
Add 45. So 10x is on this side. Add 45. 225. You divide that by 10, it moves the decimal back one time, so it's 22.5. That's your first degree. That's degrees, because this is 180 degrees. Okay, what is your second angle? This is your first angle. Second angle, you got to do 4 times that. Multiply it by 4, so what is it?
90.
90? Exactly 90? And then this will be 5 times that minus 45. So do 5 times this and then subtract 45. What is it?
45.6.
It can't be
67.
67.5 because you're gonna do 5 times this and then subtract 45.
All 5 times
5 times this, not 5 times 90. It's 5 times x. So it's 67.5. Then what you need to do is add these up and make sure they do add up to 180. They do? So you know you got it right. Okay? So triangles, always remember you have to put the 180 is what it adds up to. Okay? I think the rest of the problems, if you have trouble, you can call me, call a friend, see if they figured it out. The main thing, trying to do it on your own is draw the picture. And try to get rid of all the extra information that you don't really need. Do you have any questions just looking at it right now on either 2.5 or 2.6? Okay, go ahead and start on your homework.